Yeah.
Thank you very much for the kind introduction. I must acknowledge my collaborators with whom I worked on some of these ideas. This is an ongoing work and I have been published in it. I also wanted to thank Shan for acting as a wonderful host, creating a nice poster for my talk. We hope that we'll be able to continue our collaboration, exchange of ideas around these themes. I wanted to spend a few slides on my background. I said that you don't have to give me a formal introduction, and I'll cover it myself. So I was born and brought up in Darjeeling. So this is the thing that you see. My home was actually very close to somewhere here. And I would stare into the sky and think of this nursery rhyme, twinkle, twinkle, little star, how I wonder what you are. So if you have that wonder in you, and you start asking the questions, how and what, you automatically become a scientist. So you see the children are very curious, and by nature, they like asking a lot of questions. How, what, why. The curiosity is killed as soon as they go to the school and college. We kill their curiosity. We condition their mind, we force them to think in a particular way. If we leave them alone, I think probably they'll make better scientists and better scholars. That's my opinion. So as I told you, I used to go to my school, which was around the hill actually. So in my 10th, I attended St. Joseph's School, which is a Catholic school. And the other one I went from 11th, 12th was a Protestant school, Mount Hermon School. These schools are very old, as you can see. And Darjeeling was famous for the Christian missionary education system. For my bachelor's, I came to Scottish Church, Kolkata, and again, that's one of the oldest colleges in India. And then I did my master's from University of Calcutta Science College. And luckily, in the physics department, you still find that it produces huge number of researchers. So if you go to any research institute in India, you'll find 50% of the physicists are Bengalis. And they often say that you have to learn Bengali as the second language, otherwise you can't interact. So there's a dominance, but the thing is that they give a lot of respect to academia. And I think every institution has its own. I am very fascinated in IIT Madras, the way startups are encouraged and the industry academia connect. That again is missing there. It was missing in JNU also, where I used to teach. We are a very strong research university, but there is no connect between the industry and academia. I did my Ph.D. from Saha Institute of Nuclear Physics. And it's named Saha Institute of Nuclear Physics after Meghnad Saha, because he was known for his work in nuclear physics. Initially, it was called Institute of Physics. It was actually founded in Calcutta University and then later became an independent institute under the Department of Mathematics. I also completed what is called the Habilitation de Recherche, which is like the highest degree in France. I did from Universite Pierre and Marie Curie, which is Paris' sixth university. For my postdoc, I spent a year and a little bit more in Helsinki University of Technology. And I remember 2002, 2003, when I was there, it was one of the severe most winters. One of the severe most winters after 1939 or something like that. So, and we had temperatures as low as minus 36 degrees Celsius. And for a month, it didn't go above minus 25. So when from minus 25, it became like minus 15, minus 10, we were going around with t-shirts. So your body gets adapted to that cold weather. Then I spent 2 years in Brookhaven National Lab in Long Island, New York, which is, of course, very famous for its particle accelerators. So you see the relativistic heavy ion collider in the background. It's like 15 miles, 10 miles. So again, a few Nobel Prizes come in chemistry and physics from there. Then I joined Banaras Hindu University. will see that this is a fascinating university, one of the largest area-wise in Asia. So this is 1,300 acres. It's built in the shape of a rising sun. So Pandit Madan Mohan Maghia, who was the founder, he actually requested the Raja of Jamnagar to donate that land, and he said, okay, what
I'm sorry to disturb you, sir. In case if you can hear me, but you are not audible, there is some audio issue.
It's not
It is
audible.
audible now. So, but then the voice is not clear and it is fluctuating. So it's not clearly audible. Yeah, better.
is it better now?
Definitely. Thank you.
Thank you. Thank you. So after I completed 3 years, I got a permanent offer from École Centrale Paris. Again, this is one of the very specialized engineering schools. So in France, they have a university system, and they have what are called grand écoles, similar to what IITs are. And only top 5% of the students get admitted there. So this École Centrale was very famous for engineering, automobile, architecture. So Gustave Eiffel, who was extremely there. All the French car makers that you hear of, Citroën, Peugeot, Renault, then they are all from this university. So after spending 5 years, I was offered a position at Jawaharlal Nehru University, and I joined there in March 2014 as a full professor to start the field of complex systems. So that was a UGC initiative, the 11th and 12th 5-year plan. And since then, the 5-year plans were discontinued because the Planning Commission was renamed as NITI Aayog. And so I was absorbed there, and we started the integrated MSc PhD program in complex systems. So that was one of the first in the country. I'm very happy now that it has spread not only IIT Madras, but I hear that IIT Jodhpur and IIT Kanpur have also initiated programs in complex systems. And last June onward, I have taken leave from GNU, a 5-year long leave, and joined BML Munjal University as the Dean of Research and also the Dean of School of Engineering and Technology. So it's a very nice campus. It's a Hero Group initiative, and we have a wonderful campus. So all of you are most welcome to come and visit and be a part of BMU research and innovation. So my office is somewhere on this part of the room, and I also have another office at the academic block, which is behind this. So I wrote in the abstract, you'll see that it's a complexity science approach to social progress. So what do you mean by social complexity science? So I wrote there that there is no consensus on the definition of complexity science. But you often deal with topics which are very complex. You have already seen the effect of COVID-19 pandemic all across the world, right? And this the first case was reported in December 2019, and that's when it was called COVID-19. And then it spread, and till date we have 53.8 crores of cases, out of which 4.33 in India. Deaths worldwide is 63.2 lakhs, and in India it's 5.24 lakhs. This is from a slide of my friend and colleague MS Santana, who is in IISER Pune. And this is a plot of the waves in India. So you can see the first wave, the devastating second wave, and then the third wave, which was there last January. And now again, it's slight increase, but we don't know which direction it will go. Now, we don't know. We'll have to live with the COVID problem. And you would have seen that, when the COVID was there, public officials, administrators, health workers, paramedic staff, doctors, scientists, epidemiologists, mathematicians, everyone had to pitch, and people had to call. So it's a large, what we call issue, a complex issue which cannot be solved. That's why we're keeping on having these waves. It's not easy to prevent it. As soon as you relax the conditions, again it starts. That's been a very bad problem. So I remember in 2020, when just after the lockdown, national lockdown was announced in India, this was an article from BBC around that time, and it said that the world would face one of the worst economic crises since the 1930s depression. That's what the prediction of the International Monetary Fund, IMF, was saying. Of course, we didn't have so much actually, so the prediction was not as accurate. I also came across a very interesting article written by two scientists who were experts in complex systems from Santa Fe Institute. They were both former directors of Santa Fe Institute, and you can't read the name. One is David Kakoya, the other one is Jeffrey West. And they wrote the damage we are not attending to. And they said the scientists who study complex systems offer solutions to the pandemic. Unfortunately, most of the governments do not listen to scientists. They listen to a small extent to the economists because their economic policies and things drive the country's economy. Scientists across the world, and it's not that in India, it's across the world, they are not taken seriously. But what was interesting is that if you read an article, and it's I think freely available article, you will see that they begin with a story, and that's a quite famous story. I'm sure you all have seen. During the World War II, the United States Armed Forces faced a dilemma because returning bomber planes were riddled with bullet holes, and they needed better ways to protect them. So they collected all the data and saw that these are the bullet holes, things like that, right? And so the army said that we must reinforce and strengthen those areas where the bullet holes are coming so that they. And so they plotted this. Is this a correct approach? So the answer is no, actually, and that was pointed out by a statistician called Abraham Wald, because he said you're looking at those planes which have returned. The ones which were hit on the other paths, and these were the places where they were hit, those planes did not return. So if I at all have to reinforce or strengthen, then I should be doing this path. So that is called survivorship bias. Now I have seen, and I've seen this across institutions, people who do not have or take precaution in applying statistics end up with all kinds of wrong inference. So the army officials were actually drawing a wrong inference. They were thinking that these are the places where we should strengthen, right? But it's actually the opposite. You understand this very well, right? And this is a there is only one problem in statistics. Similarly, people have applied statistics blindly, and that's why often come up with completely wrong inferences. Now, you will see that we've now entered what is being called the fourth paradigm of science. The first paradigm, especially this is in Italian and very small to read, but that is the empirical observations part. The second one is the theoretical models and generalizations, that was 1650 to 1950. And then came computational science. Once the World War ended, a huge amount of emphasis on building supercomputers. So a lot of them there. And now we are into data science. A huge amount of data is being generated. But as I told you, I often quote this nice piece of thing from Herbert Simon. He was one of the Nobel laureates in economics and one of the first persons to apply artificial intelligence machine learning to economics. And he said, perhaps the right way to move is to understand before one predicts. I must understand the system before I start predicting. And again, like I work with computer scientists, and I see that they are often interested in prediction even before you start understanding what is going on. And I have nothing against the machine learning, theorists or computer scientists, but I've seen, for example, deep learning is not understood at all. Why it works, where it works, when it works, nothing. So you employ something and comes a result, but it's like a black box. So I don't understand. So in terms of science, I don't make much progress. And so my feeling is that there is a need to bridge data and science. Because that is going to be it. Now, often what happens in the problem that I was giving an example, the pandemic, you need a more holistic approach. If only the medical biochemical staff worked in a silo, or if the epidemiologists worked in silo, or if the public health administrators worked in, I won't be able to solve the problem. Similarly, in science, you'll find a lot of issues where you need a more holistic approach. And so this parable, which shows, that 6 blindfolded men, when they touch different parts of the elephant, think that they are different. That often happens in science. And I'll tell you some of the problems we've been working, it's like that. Now, you need to open your blindfold, broaden your vision, and then approach the problem. So you have to work in collaboration with other people. So this interdisciplinary, holistic approach in complexity science is now becoming very useful. So last year we were particularly encouraged because the Nobel Prize in Physics went to, one of them was Giorgio Parisi, and I myself had attended his lectures way back in 1999 when I was attending a program in ICT in Trieste. And that time Virasoro was the director, so they have a book, Meza Parisi Virasoro, a book on spin last year. I don't know if you have read it. And it's one of the very original textbooks and very, very well cited. And that program was on, NP hard problems, so which are non-deterministic polynomial, hard, computationally hard problems. And a lot of physicists have actually contributed to that area, including what is known as the simulated annealing, which was proposed by Ella, Becky, and Kirkpatrick in 1983. So that's one of the cited science articles published in the journal Science. And so, of course, Parisi has fantastic contributions and wide applications and domains. My student and my colleague, she's now my colleague also, we wrote an article that why the Nobel Prize in Physics going complex systems will change the way you look at science in India. And I was saying that, I was offered this position in JV to start this field of complex systems. Then, 2 years ago, I think they made a very wonderful initiative. Now I think IIT Kanpur is doing, IIT Jodhpur is doing, other places are picking up now. And it will change the system because we were very traditional and very narrow in our approach, where departments don't cross-talk with each other. We have to change the way if we have to solve problems like this. So I wrote in that abstract, for example, that complexity science doesn't have a definition, but primarily we deal with complex systems. Now, how do I define complex systems? Again, these are ones which are made up of different parts in such a way that the whole is just not sum of its parts. So something more comes. And typically, you will find a thing non-linearity, emergence, spontaneous ordering, adaptation, feedback loop. Yeah. So one of my students is working in data science approaches to studying climate change and environmental science. So you have very complex cycles. So you have different factors, and we don't know which causes or which affects something. I, as a policymaker, make a policy and make an intervention that might upset the whole ecosystem. Similarly, in social science, what happens is it's very hard to do experiments. I can't do, of course, with simulations there is a limited scope, but I cannot do experiments on people and then decide this policy is good or not. That's a big enough problem. In physics and chemistry, that's why it's easier because in natural sciences I can do experiments, then formulate a theory which match. Then I say that okay, this is a correct theory. In social sciences, that becomes a problem. And similarly in environmental sciences. So there was a wonderful edition in Science Journal, April 99, where they dealt with complex systems. And you find a lot of interesting whole issues on that. Whole issue. I would ask you all to actually read these articles because the experts, leading experts, have contributed articles there. In my own research, I have used all these different types of things: nonlinear dynamics, game theory, collective behavior, which are the statistical physicists, network theory, pattern formation, right? And often we combine more than one. Like I also hear Sharon is trying to combine, pattern formation, so Turing diffusion on a complex network. So who's working on that? He's not here. But I used to work on pattern formation using Turing diffusion, coupled diffusion. But that was the thing. Now he's doing it, so that was in a lattice space, right? Now he's doing it in a complex network. So he's combining those ideas. And we are sure that many more new concepts will come and new insights will be gained. So when I was working over last, I have worked almost 25 years in this field, 2008-9, there were some changes going on in the field of economics also. So we found very interesting articles. One of them was an article on network structure of production. Productivity is hardcore economics. They used to study productivity connected to capital, labor, technology. That is typically the way they make equilibrium models and then propose it here. This was a very interesting paper written by the group of Atelier and there were 2-3 other articles which are related but not exactly in network formulation. One was by Darren Asimov. He's in MIT. He's one of the potential Nobel laureates. Fantastic person. And there's another group called I think Matthew Jackson, also in MIT. So they're doing very good work where they're borrowing these concepts of network theory and applying it in economics. And they're studying it to study, the spreading of shocks, for example. I had the financial crisis. So suppose one institution gets affected. That would hit another institution, that would hit the shock, and that shock would propagate in the economy. How does the shock happen? So we also have a paper with Anirban and one of my former master's students from Ashoka, where we studied that demonetization. What happened in West Bengal? We got the data from the West Bengal government, and to see what was the effect of demonetization, which things were hit by that. Because small traders, for example, were expected that they would be hit. But we found that there is no effect, which is counterintuitive. But then we understood, when we went deeper, the economists told us, because how it works in most of the things, India is a very high trust society. Okay? So those who have been to France will know that France is a low trust society. And I didn't know that before going to France. And I didn't know before talking to management people. Low trust because in France, if you want to, suppose you want to join Shine, he will make you fill a 15-page contract. Everything will be written in details, right? What will happen if you do this, what will happen if you don't do this. Here, you don't even care, you just start working. Similarly, I want to make some furniture, I'll call the carpenter, and you can be sure it will take 6 months, not before that. And it is across India, that's my experience. Koi bhi come up to this unorganized sector, they'll say, and then they'll take 2 months, 6 months, you will not get here. Everything is on the word of trust. Right? I don't even make payments, or maybe I make 5,000 rupees, and he knows that I'll pay when his work is complete. Right? So this is a high trust society. You understand? Now, in social sciences, these things become very important, different, because each society works in a very different way. You are understanding what I'm trying to say. So even the productivity, distribution, labor, everything is different in each of these economies. So you have developing economics, you have developed countries, so things are not the same. We also came across a very nice paper by Hidalgo and Hausman, which is a very small little, but Hidalgo and Hausman. He was a physicist by training. Both of them were in MIT, Center for Interdisciplinary Studies and all that. And they come up with what is called economic complexity. And that is something which I will explore here. So, complexity of a country is a driving engine behind the economic growth and development process. Now, productive capabilities are important to understand the economic development. However, what exactly are productive capabilities? That's a question which economists often debate about. And how can we measure them quantitatively? Is there a way to capture and quantify that? And so, how is the complexity of an economy linked to the productive capabilities of a country? And that was the idea behind the economic complexity index. So what they said was something like this: that maybe a country can make safety pin. Safety pin is a very simple product, and another country can build a rocket. But it is expected the one who will build a rocket will also build a safety pin. But the reverse is not true. One who has the capability of building a safety pin may not be able to produce a rocket because it's a very, very complicated or complex. You understand that? So the idea was that if I have, the capability of producing something very complex, I would be able to do the simpler one. Is that clear? Now, so the complexity of a country can be interpreted from trade data as bipartite network. So what they started doing is like this. They looked at the export of the country. Each country exports, and of course it will export the one which is very good quality and something which I specialize. Right? So if India is exporting garments, then India should be at the top of the garment industry. Otherwise, other country will not import our goods. Right? Yes. I think the PNS was the first one. Then the others came. There was or simultaneously on the 1999. That one was just after this. Yeah. But the ideas were
it's the same data set.
Now, so that was the idea behind that. So what they said that if I have countries, capabilities, and products, I want to measure this, but almost like a proxy that this it becomes a bipartite network. We have countries and we have products. Okay. So the theory behind this is that I would be able to, instead of measuring the capabilities, I'll be looking at this and inferring about the capabilities. And they introduced something called the method of reflections, because like intuitively how we can understand that countries which produce more number of products are more complex, so that will give you a score for the countries. Yeah. And the products solely produced by more complex countries are more complex, so a score for the products. If there are more countries producing that, and then you keep on refining. So there is a iterative process. Okay. I'll give you an example. So if you look at their website, you will find this maths behind that. That you have a matrix. You have number of countries, you have number of products. You compute what is called the relative comparative advantage. Okay. And then I create a matrix, and then basically these are eigenvectors of that matrix. Okay. I'll skip that maths. I'll give you an example which will illustrate. And then the economic complexity index is basically expressed in terms of that eigenvector. Similarly, I can also create something called the product complexity index, okay, which will be different eigenvectors of this matrix. So what is important is that we come up with some vectors, and the different components of these vectors will actually either think of diversification, or we talk about the ubiquity of products, the whole plethora of products that you have. So let me give you a small example. On the right hand, you see that these are 4 countries: C1, C2, C3, C4. And the products are P1, P2, P3, P4. So C1 produces all 4. Yeah. C2 produces only P2 and like that. Yeah. So then I convert this into a. So what happens is the country 1 produces all 4 products. 1, 1, 1, 1. The second country produces only the P2. So 0, 1, 0, 0. Okay. You understand how I can see it. Once I have the matrix, the KC0 will be the sum of all these, and the KP0 will be the sum of the others. So I get 2 vectors, 4, 1, 2, 1. So 4, 1, 2, 1 summed across this. And this one would give me the ubiquity vector, which will be 1, 2, 2, 3. Yeah, when I sum across. And then what I'll do is I'll use these 2 vectors to go on a reflection and calculate the other thing. So KC1, 1 will be average of this vector 1, 2, 2, 3 by 4. Okay? And this one will be sum of, and this way I will reiteratively compute that, okay, till I reach a fixed point. So you will compute this KC2, KP2, KC3, and so on. So this is called the reflection method of reflections, and basically this is how you will compute. So this is just matrix multiplication, and you will come up with these quantities which are going to be used, right? So if I have data, and this is typically the data which is available in public, you will find different type of things, and then you will find that you can compute all these ECI, and you will also find Gini index, which is a measure of inequality in income, GDP, gross domestic savings, human development index, and so forth. So these data are now available. Now what we wanted to do is connect. For example, you will see if I forgot to include that diagram. So the countries which have very high economic complexity there are also the ones which have high GDP per capita. Okay. So there is a correlation. I can just show you if you just trust me a little. I think they should list of countries, and you will find. I should have included that. You will see this tag, right? So you have ECI, and this is GDP, and it has a thing. And all the ones which are on top here. So this is, for example, yeah. So this is Japan. This is Switzerland, and then you have countries like Italy, Denmark, Sweden, and Germany, and all that. Now you'll find this, for example, is the if I remember correctly, this is Kuwait. Okay, it has only one product, oil. Okay, oil is extremely rich, so GDP is very high, but the complexity is not, so it just depends on oil. Right? So very low on complexity, but very high GDP. Okay. So you got the idea how they were portrayed. Okay, so I'll go back. I'll find out. And I'll show you a thing. It's too small. It's difficult, but I'll show you. So what? Let me go back to the presentation. Yes. Can you hear me?
Yes, sir. Audible.
Okay. Thank you.
Sir, I have a query here.
Yes.
This is the snapshot at a particular moment of the time, but then economy is so very dynamic. So would it be beneficial to analyze the static networks and derive some conclusion, which may not be that much relevant for the economic networks?
Good question. So he's talking that the economy is evolving, right? And so all these things would also be evolved. And should I take a static network or a dynamic network? So what they showed, of course, the economic cycles are much slower. So it depends on what I'm looking at. So even like in finance, you find that finance is much faster, much higher frequency. Even like the daily return is now not called high frequency because you can trade in milliseconds. So you have high frequency trading, you have daily trading, then you have monthly trading. So it depends on where you want to invest. The economy is actually much slower than those scales. Right? Typically over months and years, it takes time for countries to evolve or to grow capability. So here we are talking about a much lower time scale. And that, again, people have analyzed, they looked at these windows and found that, okay, and in that paper, original paper of PNS by Heidelberg, they have said that, for example, they found that the 2007 was a good predictor of the GDP, and 10 years later it could predict the GDP. Okay, so I'll show some of these things. So what we are trying to say is that, using that method of iteration, you can actually, classify these countries. And so you'll find, this four quadrants, these four quadrants, where, this quadrant would be non-diversified countries producing standard products. The other one is diversified countries producing standard products. Third one would be non-diversified countries producing exclusive products, very small but exclusive products. Here, diversified countries producing exclusive products. So you can actually categorize and do that. How useful that classification is. So when we were doing this computation, and this was done by my master's student Ashish, who was from Ashoka, he saw that these parameters like KC0 here, or a KC2 here, or a KC4 here, start capturing this thing with GDP, okay? And it can be used as a predictor of GDP. So what happened was in this, again, this is taken from that paper. They could predict the average growth using the sort of ECI of 10 years ago. Okay. Now, similar studies were done for India by Anand Sahasraman, who was in Kriya University, close to Chennai, and a gentleman from Imperial College, and Henrik Jensen. And they studied the state-wise productivity. Okay, the product space, again, data was available from the Ministry of Commerce, and they studied similar things and wanted to. I came across another very interesting paper. Again, this one. This is just forget. I had the reference, but I somehow forgot to paste it here. Yeah, could be, but I think I have the reference somewhere. Now, I found another very interesting article written by the group of Hidalgo, which was linking this economic complexity index with the income inequality. Now, income inequality is often measured by an index called Gini. It was formulated by the Italian Corrado Gini, and it measures the inequality. So, something which is low is 0 to 1 index, lower value has more equality, 1 is inequality, perfect inequality. And so what they did is they studied this correlation between Gini index and complexity for different countries and across time. And they found that they are negative. So that countries which have much lower inequality would have high amount of complexity. Now, this is a complex question. Okay, what I want to draw attention. Suppose my country is developed. I have very strong thing in health, education. Would that, so suppose education and health, what is driving what? If I am educated, will I also be conscious about food? So if I have a good thing in health, would it, in education, would it have also in health? Or the other way around? Or so these social factors, socioeconomic factors, the causal connections between them is not. It's very difficult with that. With data sets, you cannot. So all those gradual causality and other measures, you fail to actually imply something which is very useful. Okay. But this definitely, they were studying not only the ECI but looking at, for example, the Human Development Index and other types of things, and they were trying to understand that what are the things, empirical relation between economic complexity, GDP, other index factors. So that prompted us to actually investigate further. So I said that let me look at social progress. And there was index which was created by 14 Nobel laureates, 14 economists, among which there were a few Nobel laureates like Amartya Sen, Joseph Stiglitz. So they created something called social progress only in 2014. So this data is available or created from 2014 onward, which has 54 indicators in the area of basic human needs, foundations of well-being, and all that. Okay. So what they did is they classified all these 54 needs into 3 categories: basic human needs, foundations of well-being, and opportunity. Okay. And so this is, you will find inequality in all these factors. It cannot, not only income, health, education. So when we are discussing, so in JU often students get very agitated because they come from very marginalized background. We have a very inclusive admission policy, but they will fight because like I come from a privileged class where both my parents were professors. I went to the best institutions like schools and colleges, like I showed. Somebody who's coming from a remote village, can he or she be compared to me? Because he or she didn't get that, that scope, right, the opportunity. And he and she have to struggle all the way to come to change. So when 2 students come, they are not at equal footing. You understand? So, and I'm not even talking about their previous background or generation or what they're coming from. Just if I take 2 students of this one, it would be very unfair to compare both of them because you understand what I'm trying to tell. And so these are very complex issues, and we wanted to see, again, well, this is ongoing work. I don't know how to solve that. And can I come with some indices which will capture this, or can I draw something from here which will help me to frame policies? So that is the direction we want to go in. Okay? And so I've started working with social scientists, with economists, with computer scientists, with mathematicians, and see if we can have a more holistic approach. You understand what we are trying to do here. So I also wanted to see if there was a linkage between ECI and SPI. Of course, because a lot of the factors which were in ECI maybe it's already there in SPI. Right? For example, the Human Development Index, which was formulated by the Bangladeshi Nobel laureate Yusuf. They took income, education, and health, and divided by 3. That was the Human Development Index. Now, those factors are definitely there in SPI. So, when we were looking at the cross correlations like ECI, GDP, of course, ECI, GDP, I showed that there is a huge amount of countries which have high ECI would also have high GDP. Similarly, countries which have a high SPI have high GDP, and it's even the thing is variance is even higher. The correlation is much higher. Then you see that 0.91, whereas here it is like 0.74. Similarly, like the ECI and HDI, which is the Human Development Index, and then if I look at SPI, it's much more correlated, 0.96. Of course, because all the factors which are here in HDI are also there in the SPI. Right? So these are different countries, right? Yeah. So we wanted to see what is between ECI and SPI, and the economists often run what is called the panel regression to see that if there is a strong indicator. Okay. So we did that to work with ECI and SPI and looked at different instrument variables and came up with this. I'll just skip the thing. The conclusion is basically this: that the ECI is also a growth predictor of SPI. And you can come up with a causal relationship, but more detailed studies are required. Now, when we were doing these studies, we found that beyond ECI, people have now come up with ECI, ECI plus, ECI plus plus, because the indices, you add and you refine this method and you come up with new indices. So that is something which was troubling us. The next part which was troubling us is how are these questions related to sustainability development. So there is a big debate going on within economics that neoclassical growth perspectives has been dominating economics so far. However, many economists are now discussing the holistic discussions of development, and they are saying that only GDP growth and all cannot be considered as measures of development. You have to take a more holistic view. And so people are really, so there are wonderful articles written by Schultz, Stiglitz, Lewis, Ainu, that you cannot just take GDP as a measure for development. Okay? You should have a model. So Bhutan has come up with an alternative, like gross national happiness. Because you see that happiness is a completely different. I may be, and I've seen that in my village. I come from Birbhum in Bengal. People who get a little bit of kolay, dal and posto will be very happy. They don't want to come to Punjab or go to Maharashtra to earn their living. They'll earn 2,000 rupees and they're happy. If I tell them, why don't you come to Punjab or to Maharashtra and get 15,000, happiness is a very different. You now get that concept also. Right? It has nothing to do with my industry. So if I say that, okay, as an economic agent, you should be maximizing your utility, in terms of prosperity, Maharashtra, Punjab would have perhaps as an industrial thing or more advanced farming. No, I'm happy like that. So, what should be the way to judge a country? How develop a country? Is it only this GDP and the other things, or is it only, or there are other factors? Right? That's a question which troubles the so. And so, this, yes. Yeah, so those were not taken into those. That's why these concerns came. Poverty, education, health are important things, but equity, were including them. So then they started the understanding that I have to go beyond those traditional things, and that's how the sustainable development goals were taken. Okay. So you will find that because they said that we have to think about the people, planet, prosperity, partnership, and peace. All these have to be goals, and in order to achieve them, they now designed these 17 goals, which include gender equality and everything. Okay, so
equally weighted or they are weighted?
In the Sustainable Development Goals, so that's what we come to. Our work is basically. So at present, for example, NITI Aayog has come up with an index where they take equal weights of all this. But we are saying, no, that should not be the way to go. Okay, that's the idea. Okay. He is going far ahead of me, very experienced guy. So he can see what I'm going to do. But that's the fact. Like all the goals cannot be equal, and each country might have different, because it's not a homogeneous way of living. So every country has its own history, and not only, I'm talking about political history, but also economic history and social history.
So religious freedom is also important.
Yes.
How do you quantify it?
Difficult, but they'll find proxies, for example. Like now, if you say that in India, they look at the religious atrocities, so how many crimes committed on religion, how many riots happening, those type of things, or whether you are forcing it in education. So they have different proxies of time. So, what about India? What is the problem? So in India, we have to again move beyond the physical and human capital. And so Niti Aayog developed this index, but they did not include a certain number of goals. 12, 13, 14, and 17 were left. And they give weights, equal weights to all of them. This was your thing, right? So there was another study by Observer Research Foundation. They again came up with an index where they determined the weights using principal component. But we still found that there are some drawbacks. So when we were reading this and looking at this complex situation, we came across this paper, again, the ones which had tried to reconcile the ideas between economic complexity and the ones which were proposed by the group of Luciano Pierre, that was called the fitness index. Okay. So there was a paper in Nature Communications, and that was like reconciling contrasting views on economic complexity. So they gave a nice mathematical framework to understand all the different indices that were being used. And then they used it to rank the countries. So this was published last July. And I had started this work without knowing that there was already a work existing. When I came up with the answers, then I found that that work is already published. So what I thought that let me now go to the economics and slightly change the context, that we look at the Indian data, use that same framework, and I have already explained the math, so I'll skip a little. I'll go look at the India data, come up with those scores, and then if we can, based on growth and development economics, so Sangeeta, whose photo I showed initially, is an economist, growth and development economics, how to make policies which will help the states to achieve this. That's important. The state will like to understand how can I achieve these goals. Right? That is the direction. So we are not yet there, but on the way.
What is 6 and 7? Because that's something a very high score.
Yeah, very high score. So 6 and 7 are clean water and sanitation, affordable and clean energy.
So this data you got from the Niti Aayog?
This is from the states, yeah.
From the report of
From the different, yeah. From the and like what you said, some goals are easily achievable, others are not. Yeah, 9 is, for example, difficult. So now, our thing was reckless. But there are certain goals which are more difficult to achieve, and some which are easily achievable. So the scores, the goals should have a different score. And that is why we are using this framework, because it automatically, it not only ranks those. So here I'm just showing a snapshot, for example, that Kerala has been able to achieve so many goals, and then Chandigarh, there's Haryana, Mizoram, Jharkhand, Bihar. And so what happens is you can find this is taken from the Niti Aayog. They have the index where they give equal weights. And this is the one way we are saying where we have this complexity scores for different goals, and the ranks come out using that method of reflections. Okay. And so if I compare the two, I'll see a correlation, but there is a significant variance, and that is good, which says that the two methods are different, and they will capture different things. And what Arijit was asking, then it becomes very important that 9 is very difficult to achieve, whereas 6 and 7 probably everybody achieves. Yeah. So I can come up with those scores. Okay. So once I understand this for India, then I can go and advise the states that what measures you need, okay, which thing. So what came out is that those which have complex scores are high, if you achieve those, you will find that you will be achieving the other scores, other goals which are less complex. That is also noticed. Okay. So that is how we now go to the public policy makers of the government and start saying, okay, why don't you focus this? This will perhaps increase your rate. So the concluding remarks, generalized complexity framework to study the SDGs in the Indian states, a new ranking for the states, new scoring for the SDGs, and can be used to gain deeper insights into the capabilities of the states in achieving those goals. The future directions which we were thinking, one is you can break those goals into sub-goals. Yeah, that's already done. Second, like what the other gentleman was saying, that if I have multi-year data, see how it evolves, and you can actually do dynamical network and modify these concepts, methodology, and capture those. Yeah, that's one. Third one is, first of all, when the financial crisis came in 2008, it hit a lot of countries. COVID hit all the countries in the world. So we wanted to see the effect pre-COVID, post-COVID. Yeah. And again, countries really went this and in their ranking after the COVID. And like we are saying, that there is a limited availability of quality data, especially in India. And so what we were thinking is going to the NITI or to the different agencies of the government and also collect and make a data bank which can be used to study India. You don't find all these things in one source. That's a problem in India. I remember about 6-7 years ago, Indian Statistical Institute tried to create what the other government agencies didn't. So there is a, you need to have a cross talk between the different ministries. Ministries don't talk to each other. I stay in Delhi, I know they don't talk to each other. And unless you give us the data, we won't be able to help you as a data scientist or a scientist. That's a problem. So thank you, everyone. This is my Google Scholar page, which you can all check and find the relevant papers or from my websites here. And you can always drop a mail if you have any queries or would want to collaborate or share something. Thank you, everyone. Yes. No, that was by somebody called. Yeah. So the Kalderili Petuna group and this group on Vital Prahasna, they had contrasting views. So it was, I don't know how you pronounce it, but it's right when you are yeah. And they have done very nice work. That's by Carla Schiara. They have very nice papers.
So how does oil prices factor in?
So again, very complicated issue. So in energy and oil is anti-correlated to most others. That's quite well known. But how they factor in and in the development and all becomes very, very complicated. Yeah, most of the many of the West Asian countries are basically dependent on oil, but that's a resource which is finite. What happens if once that is not a sustainable source? Right? These are fossil fuels. It will end. What happens after?
So essentially, the PCI is computed on the bipartite.
On the line. We've done similar.
So basically, it's a hypogram. So if hypogram measure is tunable to that.
That's right. So we can have different other formulations where we
Sir, I have a question.
Yes.
And this is related to my previous query, that
Yes.
how relevant is this to analyze the structural properties of a single layer network to analyze the complex system? Because interaction is the key ingredient of the complex system, wherein the entities will interact, the pattern will emerge, and within the due course of the time, the emerged pattern may not remain the same. So
Yes.
how relevant is this to analyze just the structural properties of?
So we are doing year by year. So I was showing you data for a particular year, but you can see now, generate these networks for every year, see how it evolves, how dynamical it is. Similarly, the scores will change, right? Because your economic, all the measures that you are using to compute will be changing. Right? But what we are trying to tell is that your networks have to be constructed in the same frequency as those economic variables or social variables. Otherwise, that is meaningless. So you'll have to do some preliminary analysis on the time series data that you have, and then determine, what should be my period over which I will construct those networks, and then do that. So I'm presenting some static screenshots, which you are absolutely correct. But these can evolve with time. So then you become a dynamic program. Or you can use different other techniques. For example, I was discussing that with you that when I have time series, I can look at those correlations between the different time series, build some matrix, and then use them to determine the networks, which we have already taken into account those time evolutions. So that's how we do work with financial networks. Yes.
Thank you, sir. Thank you very much.
Yes.
One comment is that this year it's been
Can you
announced
speak?
this year UNESCO has announced it as the International Year of Basic Sciences for Sustainable Development.
Right.
Is in the right direction.
I don't know, but I was working for many years, so not because this is the year for basic sciences, but of course,
Very timely.
very timely. Yeah. But that is a coincidence, not purely unintentional. Any other?
Can I ask a question?
Yes, yes, please.
Um, oh, Hi, Anirban. I'm sorry I was late. I mean, I should have come physically. I would have at least got more of your seminar than trying to log on online.
Right, right.
Yeah, but I have a small question just
Yes.
based on the little bit I got. You have constructed a associative network, right?
Right.
Right. Uh, why is it better to construct an associative network?
See, so when this idea of complexity index was being made, but so we'll have to take some proxies and make something, right? There, they were trying to judge the capabilities of the country. So instead of, how do I measure the capabilities? So they looked at the products of those countries which they were exporting. And then they built this type of network, bipartite graph, that which are the countries and what are they producing. So once they have the bipartite graph, then they come up with these scores and indices. And there could be alternate ways of doing it. So, Nilima, to answer your question, no, this may not be the best approach, but this is one of the approaches.
This is one approach to doing it. I mean, it makes some sense, of course, that, like-minded objectives. Yeah,
That's
right. The results will, of course, change completely, right? Depending on,
that-
if we do a dissortative one rather than an associative one.
that-
Yeah, okay. So it might be worth checking just via the results.
Sure.
Yeah,
Sure.
you know what results actually happen.
Thank you. Yeah.
Yeah. Okay, thanks.
So any other questions? So if there are no other questions, then we'll just thank Anirban once again for a very nice talk and for visiting IIT Madras also. So with that, we will close this session. Thank you very much for everyone joining and online as well as those who are here. So thank you once again.